Hey everyone, we're back and we're on Unit 7, Lesson 4, and today we're going to talk about some log properties. Before we do that, let's begin with our do now. Let's find each value, and we're going to do this without using a calculator. Okay, so we want to kind of like drill in this concept of what a log is. All right, so log base 3 of 3. If you can't do that in your head, if you don't know what that is, remember, you can always set it equal to x and then rewrite it as an exponential equation, and you could see real easily that x equals 1. I'm going to get rid of this work, and I'm going to remind you, remember, log equals exponent, right? So if you want to think about it this way, log base 3 of 3 means what power am I going to raise 3 to get 3? And that's going to be 1, and we saw that using algebra. So in using that rationale, what's log base 4 of 4? That would also be 1. What's log base 5 of 5? That's also going to be 1. Log base 3 of 1. Again, if you don't know what that number is, remember, it's like saying 3 to the x power equals 1. So this might be a little bit easier to see now. What power would you raise 3 to get 1? Obviously, that would be 0. So log base 4 of 1. What power would you raise 4 to get 1? Log base 5 of 1. Hope you're kind of seeing a little pattern here. ln of e. Well, ln of e, think about this, is really log base e of e. So in your head, if you think what power, right? Go back over here. Log base 3 of 3 is 1. So log base e of e is going to be 1. ln of 1 is really the same as saying log base e of 1. We know from over here, you're going to raise it to the 0 power. Log base 5 of 5 squared. All right, so this one's a tiny bit tricky. So if I don't know what I'm doing, think about setting it equal to that variable. You're going to have 5 to the x equals 5 squared. And then it's easy to see that x equals 2. So we just want to remember, always, always, always remember, y equals log base b of x means x equals b to the y. I'm probably going to write this on your notes every day. Okay, we just need to understand that these two expressions are equivalent. Okay, so today we're going to kind of summarize from up above some basic properties, right, written in a general way. So our basic properties are log base b of 1 equals 0. Log base b of b equals 1. ln of e equals 1, and ln of 1 equals 0. Okay, so these are properties you should just know. Hopefully you remember them from last year. Okay, now we're going to write them in their inverse form. This is a little confusing, so I'm just going to write them down and then we'll try to use them in some examples. So I have b raised to the log base b of m equals m. So basically what happens here with our inverses is this b and this log b are going to undo each other. And you're just going to be left with that m. Log base b of b to the r equals r. Okay. Now we could look at this property two ways, but you could see b to the r equals b to the r. Or in a few minutes, we're going to learn, and you might remember from last year, you can bring that power down in front. So there's a lot of different ways that you can kind of deal with these properties. We'll work on that as we move through the course. I will point out to you that these are pretty much some of the lesser properties that we need to know. This list over here is the ones you want to have memorized, and these two here. And again, that concept of inverse, well, the ln and the e are going to undo each other, e to the ln. I'm sorry, yeah. Well, ln of e is just one, so, and e to the ln, anytime you have these two like that, they're going to undo each other. The last property we're going to put in our notes today is the change of base formula. Log base a of m equals log m over log a, or ln of m over ln of a. And our change of base formula is when you need to rewrite a base. This becomes helpful when you need to rewrite a base. Okay, we're not going to use this one so much, but it's good to know it. It's good to like recognize when you need to use it. First set of examples, and I'm just going to bring my properties down so I could see them. Again, I'm just putting them down here so I can see them right next to me. All right, so I want to type a use log properties to find exact values. So I have 2 raised to the log base 2 of pi. Okay. As I look down my list, I'm just going to try to see and find which one this looks like. This looks like this guy here. So I know anytime I have a 2 and a log base 2, they're going to undo each other, and my answer is just going to be pi. No, that's kind of hard for you to see. And again, we don't use all these often. I'm just trying to get you guys to see certain things here. ln of e to the kt. Remember, as I look down my list, I'm going to have this guy here. So my answer is just going to be the power. Log to the base 0.2 of 0.2 raised to the negative square root of 2. Again, when I look down my list, I'm dealing with this situation. So my answer is just going to be the power. And this last one's a little bit different. I have log base 2 of 6 times log base 6 of 4. I'm having an issue with my bases. You notice how I have 2 different bases? So what I want to do is I want to rewrite each of these logs using the change of base formula. So I can rewrite log base 2 of 6 as log 6 over log 2 times log 4 over log 6. And now I can cancel. And I'm left with log 4 over log 2. And now the nice thing about any of these properties, you can move in either direction. So I can take this and go backwards to that. So this is really log base 2 of 4. And hopefully you guys can see by now that log base 2 of 4 that's a power. What number do I raise 2 to get 4? And the answer would be 2. Okay. That one's a bit of a challenge, I think. Okay. Now let's list some more properties. And I could have typed these out for you, but I think it's important that you understand and you write them yourself so you understand where to put the little lower thing. So log base b of m times n. So when I have two things being multiplied together, that's going to be log base b of m plus log base b of n. And similar to exponent laws, when we multiply like bases, we add the powers. Log base b of m divided by n. When we divide like bases, we subtract the powers. And lastly, we have log base b to the m raised to the r power. So if I have something as a power, we can bring the power down in front. Now, anybody that had Mrs. Stevens as a teacher last year, she calls that throw the cowboy off the horse, right? But we just kind of bring that power down in front. Or throw cowboy off the horse. I've still yet to understand what that means, but in my experience, students that have had her seem to remember that. Let's just take a quick moment right now and take and redo this guy here. See, if I was doing this problem, I would probably take this power and put it down in front. Ln of v, and I know ln of v is 1, so that's just going to cancel out, and I'm going to be left with kt. Okay. So that's what I meant, that there's always like kind of a different way that you can approach things if you understand how your properties work. Okay. These properties here, huge, big. We're going to be using them a lot. So I'd like you guys to have a basic understanding of how they work. So let's say I'm given this information. Log of 2 equals 0.301. And this is actually, I'm going to take a moment right here and go into my calculator. If I evaluate log 2, remember, when I hit the log, that's really log base 10, but I'm doing log 2 and hit enter, I get 0.301 as my answer. I don't know if you could see it. I don't know if I'm in the way. But so you get that decimal. So we're going to be using actual physical numbers to evaluate these. Log 2 is equal to 0.301 and log 3 is 0.417. So if I want to find the log of 6, what I could do is I could rewrite 6 as 3 times 2. And there's my m and my n. And now I can expand this and write log 3 plus log 2. And I know that log 3 is 0.417. And I know log 2 is 0.301. If I add these two numbers together, I didn't do this math out. 8.718. Now I'm just going to go back for a second and hit log 6 on my calculator and see what I get. Oh, I added wrong. You get 0.778. Or I copied something down wrong. Leave it to me. Sorry. Yeah, log 3 is 0.477. That's my bad. Log 3, this should be 0.477. And then it should work. And let's try the right number with log 12 now. So we could rewrite log 12 as log at 4 times 3, which is really log 2 times 2 times 3. So I would have log 2 plus log 2 plus log 3, 0.301 plus 0.301 plus 0.477. Again, I did not do that math before. 0.477 and 0.602. It should be 1.079. Let's try it and see what we get. Knowing me, it'll be wrong. Nope, we got lucky this time, 1.079, okay? But really, all I wanted to show you, because now we're gonna move and we're gonna do this with X's and Y's and stuff that might not make sense to you. So I kind of wanted to show you that log properties do work, they do make sense. Rewrite each of the following expression using log properties. So in this case, we want to expand this. Okay, we want to use our properties and expand what's happening here. So I have ln of e to the fourth over x. Okay. I have a numerator and a denominator. So that's division. So I'm going to use m over n. ln of e to the fourth minus ln of x. And ln of e to the fourth, whenever you can evaluate or simplify more, you should do that. 4 ln of e minus ln of x. ln of e is 1. And we're left with 4 minus ln of x. And you may not necessarily get number answers for these. Sometimes you will if the values work out, but all we're doing is rewriting these expressions. So your answers are going to have x's in them. In the next example, log base a of x times the square root of x squared minus 1. First thing I want to point out to you is that our log properties do not apply to square root signs. So whenever you have a radical sign, you're going to have to rewrite it with a fraction power. Now I have two factors. I have two factors there. So this is going to split up and be rewritten as two logs, both base a. Log base a of x plus log base a of x squared minus 1 to the 1/2 power. And I could take one more step now, and I can bring my power down in front. Log base a of x plus 1/2 log base a of x squared minus 1. I can't do anything with that second parenthesis there because there's a subtraction sign. Okay, so you're done. You're only dealing with multiplication. In example 3, I have ln of x squared over x minus 1 cubed. So I have a numerator and a denominator. Okay, so we've got division going on. Ln of x squared minus ln of x minus 1 cubed. Now I want to take care of those powers, so bring the power down in front. 2 ln of x minus 3 ln of x minus 1. Again, all we've done so far is rewrite it as an equivalent expression. In example 4, I have log base a of x cubed times x squared plus 1 over x plus 1 to the fourth. I just want to point out here, look at your factors. X cubed times x squared plus 1, and I want to try to get another lighter color, x plus 1 to the fourth. I have 3 different factors. I'm going to see the word log base a 3 times. In between the top is going to be a plus, and then you're going to subtract the bottom. I start by simply rewriting any radical sign with a fraction power Now I can break this apart. Log base A of x cubed plus log base A of x squared plus 1 to the 1/2 minus log base A of x plus 1 to the 4th. Now you could deal with your powers. Some of you, the more you practice, you'll start bringing your power down right away. That's okay. Ugh. And just for this one example, I kind of want to just show you. I'm going to do it in the step above. That's your x cubed. There's your x squared plus 1 to the 1/2. And there's your x. Okay. So you see how we broke the three components apart. Now we're going to go in the opposite order. So now I'm going to have something expanded and I want to smush it back together. Okay. So now I'm going to flip my power back up first and then do the in-between. Log base A of 7 plus log base A of 3 to the 4th. Log base A of 7 times 3 to the 4th. That's going to be 7 times 81, I believe. And I can't remember what I got for that answer. Seven times 81. So this is going to equal log base A of 567. I think the ones with the x's for these examples are a little bit easier. Okay, so let's look at number 2. Okay, it might make a little bit more sense. Bring your power up first. Log x squared plus log y to the 1/2. The plus sign tells me I'm going to multiply. Log x squared times, now I have y to the 1/2. So when I write my final answer, I want to kind of put it back in its square root sign because that's probably how the problem would be given to you. We have ln of x squared minus 5x plus 6 minus ln of x minus 2. Minus sign. So my minus sign, I'm going to take and I'm going to divide. Now, what we want to try to do in these examples is if we kind of can see that something can be factored and simplified, we should try to do it. X minus 3, x minus 2 over x minus 2. And that would be an equivalent expression. In example 4, I have log base A of x plus log base A of 9, plus sign. I always look here, a plus, and a minus. So I'm going to multiply x times 9. Oh, and x squared plus 1. So 9 times x squared plus 1. And we're going to be subtracting or dividing, divided by 5. So these examples, they're not too challenging, but they do take practice and you have to be careful. In question 25, ooh, this is going to, oh, actually, let's do a different one before we do the last one, 25, question 5. So let's do question 4a. Okay, I have another one here I'd like to kind of look at. A little simpler. Okay. So an example like this, I'm going to throw my powers back up because this is more of a calculus situation. And my plus sign, right? With my plus sign, that tells me I'm going to multiply my arguments. So I'm multiplying this times this. When I multiply like bases, remember I add the powers. Okay. So basically our goal is to get 1x and 2 plus 1/2, 4 halves plus 1/2 is 5 halves. We could write this answer like this. We could leave it like that. Sometimes you may see this expressed like that. Either answer is acceptable. And the last answer, the last question, I'm actually going to let you struggle with it on your own for a little bit. And I'm just going to kind of write the answer down for you and see if you can get there. Okay, so I'm going to leave you with that one fun one to practice on your own. Okay, thanks, guys. Have a good day.